Okay, session 3, module 2, part 2 of consumer chemistry. This is on naming hydrocarbons. Let's go. For today, let's have 4 things as our goals. The first one, to have a short review. For the second and the third, the naming of these alkanes, alkenes, and alkynes. And number 4, the different examples and the activities. A short review, hydrocarbons. The main topic last meeting was about hydrocarbons. When we say hydrocarbons, they are the simplest organic compounds, and they only consist of elements carbon and hydrogen. They can go straight chain, branch chains, or cyclic chains, and that means there are thousands of them. So chemists try to represent them in different models. We have a molecular formula, which tells us the ratio of the different atoms that are there in that molecule. The structural formula, the ball and stick model, the space filling model, and the one that we commonly use, the bond line diagram or the line diagram, which is like this. So by the way, there is no methane for the bond line diagram because it's only one carbon. In a line diagram, every vertex and every end represents a carbon, and the line represents a carbon bond. Okay, what is that hydrocarbon that contains only single bonds? Only single bonds. These are saturated hydrocarbons. Saturated hydrocarbons have, for example, the carbon all has single bonds. All of its capacity to make bonds with hydrogens are fulfilled, whereas the multiple bonded ones, double bond, triple bond, these are what we call unsaturated hydrocarbons. Okay. The alkanes, the alkenes, and the alkynes. So the general properties, let's have a summary. Alkanes, they have single bonds only. The general formula, the ratio between the carbon and the hydrogen is C sub n H 2n plus 2. For the alkenes, just have to change the fourth letter. So these are made up of at least a double bond. And then CnH2n is the general formula. For the alkynes, they are made of at least a triple bond. So when you see a double bond and a triple bond together in a chain, when there's a triple bond, it is directly considered as an alkyne. Okay, the general formula is CnH2n minus 2 this time. So we discussed about these different formulas in the past video. Okay, in writing, naming, and describing organic compounds, we use roots or prefixes and also suffixes to describe that whole compound. So for roots, it tells us the number of carbons present in a chain or a ring. So you have to familiarize these different prefixes. We have the meth, stands for 1 carbon S, 2, prop for 3, but for 4, pent, hex, hept, oct, non, dec, and so on. So just a little tip, so memorize these prefixes to better have a quick response when naming these kinds of compounds. And also the suffix is the end part of the name, and this describes the type of carbon bond present. So if you have a suffix of -ane, this is an alkane. For example, this 3 carbon all single bonds, propane. If there's an ene at the end, this is an alkene. just like pentene. And octine, this is an alkyne. We have a suffix of "-ine." Okay, naming hydrocarbons. The IUPAC, or the International Union of Pure and Applied Chemists, devised this system of rules to properly name these compounds, to properly indicate these different branches, because they can go branch. So they can go straight chain or branch chain or cyclical. Straight chain, for example, a long chain of carbon, just like this. Or so just fulfill your H, right? H. And then also the C, you can go down, side, and up again. Okay, this is just a straight chain, but you can have a branch chain one. So C dash C. These are like extra branches. So if you complete your hydrogens and so on, so these are branch chain. You can also have cyclical with your H. Okay, so this can go cyclical as well. So the IUPAC devised a system of naming for this. So when we say branches, the technical name for this one are substituent groups. There are different types of substituent groups. For this one, we have alkyl group. Alkyl groups are derived by removing a hydrogen from an alkane and given by the symbol R. So when you see this R dash symbol, R dash, it is used to represent an alkyl group. And how do we name these? So the alkyl groups are named by dropping the dash "-ine from the name of the parent alkane and adding the suffix -il. Okay, so drop the "-ine and change it with -il. For example, methane. So drop the "-ine, change it with -il, so it's methyl. How does it look like? The methane has 4 hydrogens around it. The methyl, since we are to remove 1 hydrogen, it only has 3. And this side here now is free to bind to be a branch to any long chain. These are the 8 most common alkyl groups. So we have this a little closer. So the first one, methyl, only 1 carbon but only 3 hydrogens this time. So the line angular formula is a straight line. And then this is the parent chain here. And then this is the carbon with 3 hydrogens. Okay, the ethyl connected to a parent chain. PC, by the way, stands for parent chain. Okay, so another one, ethyl. So there's 2. Propyl, 3. Isopropyl. So isopropyl is an isomer or a structural isomer of propyl. Why? Because there are 3 carbons, but it's a different arrangement, right? So if this is a propyl, this is an isopropyl. It seems to branch. So the carbon here has 2 carbons attached to it in this kind of formation. Next, butyl. Butyl also has different kinds of formations. You can have this straight line butyl or the isobutyl, just like this, or the sec-butyl. Secondary carbon is bonded to 2 other carbons, bonded to this and bonded to this, just like in this line angle drawing. Okay, the tertiary butyl, tert means tertiary. It means that the carbon is bonded to 3 other carbons, just like this. This and this. Okay, so this is the bond line angle formula. So most of these, especially the isobutyl, sec-butyl, tertiary butyl, and isopropyl, are common names, but they also have these technical names also. I will provide also in the next meeting technical names for this one. But Monanisha, if you see this, derecho isopropyl, isobutyl, secondary butyl, tertiary butyl, and so on. Alkanes. How do we name alkanes? So the IUPAC system for naming alkanes, the first rule is to find the parent chain. This is the trick of looking for the longest continuous chain of carbon atoms. Continuous and longest. Use the appropriate root and the suffix --ine. So for this one, we have 1, 2, we can go from 1, 2, 3, 4, 5. So we have 5. So this is a pent pentane. Pentane. Here, 1, 2, 3, 4. We can go a straight chain of 4 carbons. This is a butane. Butane. Okay. How do we name alkanes? Number 1, find the parent chain. Use appropriate root and suffix. What is the longest line that we can make? From here to here. We can also have from here to here, or just here to here. So the longest line that we can have is either starting here or starting here. It would be better if we just follow the straight line. This is how many? The straight chain has 1, 2, 3, 4, 5, 6, 7. So this is a heptane. Okay. And then next rule, number the carbon atoms starting from the end closest to the branches so that the numbers are as low as possible. So the rule is that we have to get our numbers as low as possible. We then start at the left or the right. So which side is closest to a branch? So as we go here from 1, 2, we see a branch right away. So continue 3, 4, 5, 6, and 7. So if we start our 1 here, it takes like a long time before we get to a branched carbon. So that's wrong now. So make sure that it's the end closest to a branch. Next rule, identify any branch and their location number. So first, let's have for number 1, the parent chain is a heptane. And then identify any branch and their location number on the parent chain. So this branch is this is a methyl, and it's located chain 2 carbon 2. So this is 2-methylheptane. And then how to write the name? To write the complete IUPAC name following the format, number of location if necessary. Usually if it goes from 3 to up carbons, we have to write the numbers, okay, or if it's not symmetrical. And then have the branch name and the parent chain. So how do we name this carbon? We name this as 2-methylheptane. Is it right? Yes, we are right. This is a 2-methylheptane. And then how about this one? Try. Where should we start writing our numbers? Should we start from here? 1, 2, 3, 4, 5. Or should we write it like this? 1, 2, 3, 4, 5. Which is the correct one of writing this compound? Well, because this end has a lower numbered carbon that has a chain, we have to follow this. So how do we name this one? This is a first parent chain is a 1, 2, 3, 4, 5. This is a pentane. And then we have a branch, a methyl. Again, a straight line. This is just a methyl. So it's at carbon 2, so 2-. So the name is 2-methylpentane. Alright, next. Naming alkanes. If more than one of the same branch exists, use a multiplier to show this. So we have multipliers such as di, tri, or what other multipliers? We have tetra, penta, and so on. Okay, so this one is named as dimethylpropane. Why? First, count the longest chain. We can have it here, or have it here, or have it here. Our longest chain would always be 3. And then, next, this is, because we have the longest chain of 3, this is a propane. And then, this side here is a methyl, and this is a methyl. So 2 methyl, so dimethyl. And then these are located at 2, so 2,2-dimethyl. 2,2-dimethyl. 2,2-dimethyl propane is a name. But we can just eliminate these two. We can eliminate these two because it is symmetrical here. If we do not write, you just have 2-methyl propane. Same ra gyapon ang resulta, so dili ra ma-confuse. So if it's just symmetrical on all sides, just like this, so okay ra og dimethyl propane. How about this? Challenge. So pause this video to draw yourself a 2, 4, 6 trimethylheptane. Okay, draw. Try not to answer. How do we do that? 2,4,6-trimethylheptane is like you follow the parent chain. So heptane, how many? 4, 5, 6. This is 7 carbon. Then ane, single bonds. And then number 1, 2, 3, 4, 5, 6, 7. And then the trimethyl tells us that there are 3 of the methyls. So it's at 2, and it's at 4, and it's at, this is the wrong one. Okay, and it's at the 6th one. So you just continue writing your hydrogens. H. This would take like a long time, really. Structural formulas take a long time to write, but they are much clearer, foolproof. Di ka masayop kung mag-write kag sugod sa structural formula. Okay, this is now your trimethylheptane. How about we write the condensed formula? So just follow what is there in your structural formula. CH. Your CH has a CH3, and then a CH2, and then a CH. Oops, it's okay not to write a branch. Okay, oops. CH, where are we? CH and another methyl, and then CH2, CH, CH3, and then CH3. If there are any mistakes, it's just point it out in the comments. I would be glad to know. Okay, how about we write the line diagram? So to write the line diagram, first draw the parent chain. How many are now? 1, 2, 3, 4, 5, 6, and 7. And then at 2, there's a methyl. At 4, there's a methyl again and another methyl. So this is how it looks like in bond line diagram. Okay? Easy. If different branches exist, name them in alphabetical order. So we can have different branches at the same time. So just like this one, the longest continuous chain has 6 carbons. Therefore, this is a hexane. Then there is a methyl group branch at the 2nd carbon atom and an ethyl group branch at the 3rd carbon atom of the parent chain. So with the branches named in alphabetical order, the compound is 3-ethyl-2-methylhexane. So you write your ethyl first because it starts with E. This is goes before M in the methyl. But remember, when we start numbering, we really start here because this is closer to a branch than when we start here. 1, 2, layo pa ka para maabot na nasa 4 ang imong first branch. So again, lowest numbers as possible. So this one, you have a branch at 3. What are our branches? You have a methyl at 2, and you have an ethyl at carbon 3. But para to write the name, i-arrange nimo si alphabetically. So E first, so 3-ethyl dash 2-methylhexane. Okay, ethyl before methyl. Okay, so ano siya ha? When you alphabetize, do not include the tri, tetra, and so on, and also the sec and the tertiary. Okay, for those that are included, we have iso and also cyclo. We will learn about cyclo later. If there are more than one branch but of the same type, nagbalik-balik sila, allocating number is given to each branch and a prefix indicating the number of that type of branch is attached to the name. The numbering prefix does not, yes, like I said, it does not affect the alphabetical order of the branches. So try to draw the structural formula for 3,4-dimethylhexane. Dimethylhexane. So 3,4-dimethylhexane, parent is hexane, so 1, 2, 3, 4, 5, 6. And then single bond because it's an ane. And then dimethyl, meaning duha ka methyl ang naa. Where? Naa sa 304. So 1, 2, 3, 4, 5, 6. Naa sa 3. You can have it here or pwede po sa ibabaw. And also, naa sa 4. So just continue writing your hydrogens. Wow, it takes a long time. Okay. And how to write the structural formula for this one? Just copy CH2, CH, CH3, CH, CH3, CH, this is a 2, and this one. And then the line diagram. Draw your hexane first. 2, 3, 4, 5, 6. Is it right? 1, 2, 3, 4, 5, 6. And then at 1, 1, 2, 3, 4, 5, 6. So your 3, if there's like a vertex, kung asa kayo mo tip niya, you can extend that one para sa yung branch. It's okay to go here. You can also go here, but it's better. Oh, it's erased again, just like this one, upward or downward. So if you draw na to ang structural formula, a line diagram, 1, 2, 3, 5, 6, 3. Again, yeah, that's pretty much it. 3,4-dimethylhexane. The locator is written and also the prefix indicating that there are 2 methyls. Summary: find the parent chain, use the appropriate root and suffix, number the parent chain carbon atoms starting from the end closest to the branches so that the numbers are lowest as possible. Identify any branch and their location number on the parent chain. Use the suffix -il for the branches. And then, if more than one of the same branch exists, use a multiplier to show this. Remember to include all the numbers. You can, if it has attached to a single number, for example, 2. So, pwede na jud 2, 2. Example, 2,2-dimethyl. It's okay. Next, if different branches exist, name them in alphabetical order. From both sides, gani, same as like distance to a branch. You need to write the numbering first para ang mauna sa alphabetical mo yung lowest number. Just find out which is the longest chain. Number 6. Separate the numbers from numbers using commas and the numbers from words using dashes or hyphen. No extra spaces. Okay? Don't forget, the questions at exams will ask you to write about structural formulas or condensed structural formulas or line structural formulas or bond line. So you must be able to comfortably draw any of these 3. Okay. Practice. Write the IUPAC name for the following. Okay, so you can pause the video. The name of this one is, where should we start counting? Here or here? So this side meets a branch right away. So just 1, 2, 3, 4, 5, 6, 7, 8. You can have, how about if we start counting from here? 1, 2, 3, 4. No. 4, 5, 6, 7. So this is just a 7. So the longest line is really 8. So find ways jud para makita mo sa longest line. Accounting, so 8, so octane. And then you have, this is a methyl and this is a methyl, so dimethyl. Where? It's at 2 and 5. Una ang smaller number, dash, because it's a number and a letter. And then this is a propyl. Your propyl is found at where? It's at 4. So what to write first? How to alphabetize? So do not include a di, so it's M versus P. Which comes first? LM, NOP. So M first. 2, 5, dimethyl, dash 4 dash propyl. Okay, 2,5-dimethyl dash 4. Oh, we forgot the octane. Yeah, so don't forget the parent name. Correct the following names. So we did this in class, and you can do this again. You can pause the video. The answer for this one. This is named for ethyl 2-methylpentane, but actually we should start numbering from here. Can I branch up? Or here? Where? Let's find the longest chain first. If we go from here, 1, 2, 3, 1, 2, 3, 4, 5. 5 carbons. If we go from here, 1, 2, 3, 4, 5, 6. We can make a longer one. If we have this 1, 2, 3, 4, 5, 6, we can also have a long one. So I would prefer the straight line and a going down. So that's how I have the blue names. So let's erase and clear the board first. So 1, 2, 3, 4, 5, 6. So now this is a hexane. You have a branch of 2 at 2, a methyl, and another methyl here. So this is actually not a 2-methyl but a dimethyl, where at your 2 and 4. So 2, 4. 2, 4, comma, this is comma, 2, 4 dimethyl. Methylhexane. Let's erase this first. Okay, always look for the longest chain. So what's the name again? 2, 4 dimethyl hexane. Okay, this kind of alkane, this is not branch, but this is still straight. But this time, this is branch and this is the branch. Okay. How about this? 4,5-dimethylhexane. So start here again because this is closest to 1, 2, 3, 4, 5, 6. So this is a hexane, but you have a branch at methyl 2. So this is methyl 2-methylhexane. Oops. And another here. So this is a mistake. So it's 2 branches actually. So it's a hexane, but the dimethyl, and it's found at carbons 2 and 3. So the name is this one. 2,3-dimethylhexane. So want branch numbers to be as low as possible. Okay. Insight. Think about this. Draw a compound that has a molecular formula of C5H12. So any form, basta lang kayo 5 ka carbons and 12 ka H. I'll give you a minute to do that so you can pause the video. Pwede straight, pwede branch, pwede circle, if you can. Okay, so when we try to write C5H12 in different forms, you can have this straight line pentane or this methylbutane. So methylbutane also has 5 po diyang carbon, 1, 2, 3, 4, 5, and if we count the hydrogens, it's also 12. So the same sila molecular formula. So these are what you, oh, and also this dimethylpropane, 1, 2, 3, 4, 5. So also C5H12. So the same sila formula but different structures. That is what you call structural isomerism. Structural isomerism. Compounds with the same molecular formula but different structures. They will have different chemical and physical properties. Bisa gamay lang isbukan ng mga chain branch nila, mausab din ilang mga boiling point, ilang mga reactivity, ilang mga physical properties. Pwede mo ba more on liquid form ba sila or solid form? Yes, it is based on how they are arranged molecularly. So each of these three isomers of C5H12 has different physical and chemical properties. So again, has isomerism. Same silag molecular formula, lahi silag urma. Now, naming alkenes and alkynes. Finally. So to name this alkenes and alkynes, we follow the IUPAC system, and that it lies in the ending of, very easy, dash in and dash ein, respectively. So if the ending dash in is there, it tells us that it contains a carbon-carbon double bond, and the ending dash ein tells us that it's a carbon-carbon triple bond. Okay, first, find the parent chain. The parent chain must contain the multiple bond, even if it's a little shorter. If you can find a longer one, pero wala na igo imong multiple bond, sayop na ka. So, dapat included ang multiple bond. If the bond is a double, the suffix would be dash ein. If it's a triple, a dash in, and then if triple, dash ein. Count the carbon atoms, so that the multiple bond will be on the lowest possible number, and then indicate the number that the multiple bond falls on directly before the suffix. So this is naming branches before pod. So like this, kanisha kay, this is the type of a butene. Na siya double bond, but this double bond is indicated nga naa siya sa first carbon jud nag-start. So but 1 in, and this one po butene gihapon, but it's at carbon 2 nag-start ang double bond. So this is named but 2 in. You can write the 2 before the suffix. This is actually the new IUPAC system. Okay, before, you can see your module and your books having like this, 2 in, but now it's hex 2 in. I will consider both. Okay, since I was not the one who made your module, and then I also knew that in science we have to update and follow the updates as much as we can. But just so you know, the new one is written actually like this na jud. Hex 2 in. So they updated this for some reason. Maybe if the more complex na yung chain, magalibog na di ay. So mauna siya nga ilang gi-write ang 2 before sa suffix nga in. But both are okay. Again, draw the following as condensed structural formulas. Condensed. So 4-methyl pen 2-ein. So if this is ein, you know it's a triple bond. Na ay naa siya sa 2. So first kay pent man, so 5. Try to write down. Kuan first, structural sa 1, 2, 3, 4, 5. Okay. And then it's 1, 2, 3, 4, 5. So your triple bond is at 2. So you just add you make your triple bond here, and then your branch of methyl is at 4. I want to write it this here. So tiwaso na lang H. Okay, that's it. And then your condensed, it's CH3 C triple bond. You can write the triple bond. No need to write the lines for the single bond. C, and then CH. At the fourth C, you have a methyl, CH3, and then CH3. So that's it. Are we correct? Oh, it started with Ni-start siya sa murag, what's that? Ni-start siya sa other end. Okay. Let me show you the answer niya. Yung answer kay kani. Na-start siya dire. But same gyapon. How about methyl propene? So you can pause the video and the answer is like this. So mao gihapon. This time wala na niya gi-write-an og number because understood naman nga nag-start na siya sa 1, especially when the parent chain has less than 3 carbons. Mo jud na sa dili na sila sulatan og mga numbers unless it's necessary. Okay, name the following. So you can pause the video again. Okay, this and this. Okay, here, diba? Hex 2e na siya sa second carbon. At 5 na kay methyl. Okay. It is possible also for a molecule to have more than one double bond, and these are called alkadienes. Alka. So have the same general formula as alkynes. So -2 because gibalik-balik imong double bond. If this is the case, indicate both numbers where the double bond is formed and change the suffix to diene. Diene means duha ka double bond ang naa. We said tri-ene and so on. If it's a really long one. So try. Draw buta 1,3-diene. Buta 1,3. I like the blue color this time. Okay, so buta meaning upat ka carbon. 1, 2, 3, 4. And then diene meaning 2 double bonds. Where? At 1 and 3. So name first. Okay, so 1 and starting at 3. So just continue your lines. H. Okay. So to write your line diagram, 1, 2, 3, 4. So first at 1, and then at 3. So just like this. How about this? The IUPAC name of the following. This is also a butane, but a diene, and it's at 1, 2, 3, 4. So it's at 1 and 2. So 1, 2 diene. So the name is 1, 2. No. It's the name is first the parent name buta. It's A because this is alka. Buta dash 1, 2 dash diene. Yep, we're good. Okay, cyclic hydrocarbons this time. Naming cyclic hydrocarbons. Cyclic hydrocarbons have carbon atoms joined to form a ring. So cycloalkanes, we call them cycloalkanes, and also cycloalkenes, cycloalkynes. Cycloalkanes contain saturated hydrocarbons, saturated carbon atoms in the ring, whereas cycloalkenes have double bonds in the rings. Cyclic hydrocarbons have at least 3 carbons in the rings, and the most abundant of them have 5-membered and 6-membered rings. Okay, so these are just facts about alkanes, so you can read this in your module also. Just a few things to take note. Alkanes, the major sources of alkanes are natural gas and petroleum. So the natural gas consists of approximately 90 to 95% methane, 5 to 10% ethane, and a mixture of other low boiling alkanes, chiefly propane, butane, and 2-methylpropane. Ang petroleum, ano siya. So how do we get these? How do we obtain them? We have this process called fractional distillation. I will link a video also about this fractional distillation. Okay, and when we say cycloalkanes, masyag alkanes, but nituyok siya na close, and then na-form siya og ring. Okay. This process again, this is fractional distillation. So it is heated and preheated, and then it's set in a column, and at the bottom ones, mapunta dito ang mga more carbon na mga alkanes. So 20, 16 to 20 at the top. Dito na mga lighter ones. So C1 to C4 hydrocarbons, C5 to C12 hydrocarbons, kerosene around C12 to C6, fuel oil, C15 to C18. So muna siya nga ma-separate unya mag-gas form diri kuhaon sa ibabaw unya diri kay magka-heavier na siya, magka-solid ni sila asphalt. Murag closer na gay siya sa liquid pa di ay liquid, and then this one duol na siya sa gas form. So in ani pag-separate fractional distillation of petroleum. Okay. All the petroleum can have this gasoline, kerosene, fuel oil, lubricating oil. Sila. Pwede na sila makuha tanan sa petroleum or crude oil. Okay, these are different examples of cycloalkanes. So as you can see, single chain, close lang yun siya. Single bond, I mean. You can have cyclopentane. So take note na word na cyclo. Cycloalkanes, naa siya double bond. Unya, cyclo po diyang name sa sugod. But in na lang, in. Okay. Cycloalkanes. Based on evidence, chemists believe that organic carbon compounds sometimes take the form of cyclic hydrocarbons. They form a closed ring. The general formula is likened to alkenes, so CnH2n. Two less hydrogens are present than in a straight chain alkanes because the two ends of the molecule are joined. Are they still saturated? Yes, because they only have single bonds, and the amount of hydrogens bond amount is the maximum one for bonding with hydrogen. So cyclo compounds will have a higher boiling point than their straight chain partners because there is an additional bond present. Nag-closed ring pagid sila, so mas harder i-break. Examples. This one is the model for cyclopropane. Cyclopropane. So 3. Ituyok nag-combine na close. How to name cycloalkanes? Cycloalkanes are named by placing a prefix cyclo in front of the alkane name, like cyclopropane, cyclobutane. If branches are present, you treat the cycloalkane as a parent chain. If dili kayo taas ang branch, and identify these branches. Since there is no end at which to start your numbering, kay close man ang chain, use the lowest numbers as possible for your branches. Okay. Again, you use the starting with cyclo and the name of the substituent in the ring. Name each substituent in the ring. No need to give the substituent a location if only one. Just like this. No, duhara de. But if only one, no need to give the substituent a location number. If there are two or more, number the ring beginning with a substituent of lower alphabetical order. Again, maog hapon ni alphabetize. Okay, what is included in the alphabetization? Gani, apil ang cyclo na word, apil po ang iso. Pero ang cyclo kay if branch na nimo imong cyclo. Na po yung time na taas jud kay imong ring. Sometimes. Yeah, imong branch kaya na ra di ay. So this can be a parent one. So kana jud imong parent chain. So for these cases, kuan ni when hydrocarbon are parent chains. Okay, just like this. So you start numbering with your double bond because kuan naman siya cycloalkene. In naman ni. So 1, 2, 3. Makita ni mo ang imong isopropyl first. This is an isopropyl. Take note ang yang forma kay mura siya fishtail. Methyl nimo kay one line. So unsay unahog sulat ang imong I kaysa sa M. So mao diri ka patuyok. Kay kung moari ka diri, no, mudako na imong number sa isopropyl, it will become mahimo naman siyang 1, 2, 3, 4, 5. So mahimo na siyang 5. So dili na pwede. Okay. Isopropyl dash for methyl, then cyclopentane. Okay. Use a cyclo, then pentene, because there's a double bond at 1. So, pwede rag dili ni bubutangan o pent dash 1 dash in. How about this? Tertiary butyl for ethyl. So, kani apil do not include the third, not included. Oopsie. Not included in alphabetization. Yes, ang included pwede apil si isoapil, pero ang third kay dili ra. So start with B versus E, una jud ang B. So mag-start kag number 1, 2, 3, 4. Imong number 1 imo si tertiary butyl, this one, and your ethyl, this one. Okay, and cyclohexane. Name the following. How about this? These are mga 1, 2, 3. You can have 1, 2, 3, 4, 5. This is a pentane. Single bonds. Unya na kay duha ka methyl. So you can have 1, 2, methyl, cyclopentane. How about this? Again, basta only one on chain, no need to write the number. So pila man ni 1, 2, 3, 4, 5, 6. So this is a cyclohexane. Cyclohexane, and your branch is an ethyl. So ethyl cyclohexane. Yeah, we got it right. For cycloalkenes and cycloalkynes, same gihapon ang system, but the numbering begins with a double bond. If there's a double bond, the carbons of the double bond are carbons 1 and 2, in lowest numbers as possible, just like this example. Your carbon 1 must be this and your carbon 2 is here. If you start numbering here, wala man kay double bond diri na part, so no. Okay. The numbering must again be carbons 1 and 2 and double bond. Try 3-methyl cyclohexene. I want the blue pen. Is it right? 3-methyl cyclohexene. So una kay cyclohexene. So 6, 5, 6, and then you have hexene. So among first kay na diri 1, 2, so 3, 4, 5, 6, and then the methyl is a 3, so ana ra siya ka simple, just like this. Okay, I think we're done. So yes, so these are the some of the rules. I think there are things could really get complicated. This could like have secondary branches within a branch, but dili lang na to include. So ari lang to sa simple sa. So first the alkenes. Is it again? First atong giname kay ang mga alkenes, ang mga alkanes di ay, and then we had alkenes and alkynes, ang mga cyclic hydrocarbons. Yes, so that's it for this meeting, and next meeting we'll try to have more examples of this one also. So thank you so much for reaching at this point of the video, and I'm also glad that you all participated in the online class. And for those who are watching from the modular, thank you for taking the time and the initiative to watch the video and learn by yourself. So I really appreciate everybody's effort. Let's continue.